Good morning, good afternoon, or good evening, whatever time you're watching this educational video. I will be presenting one problem that is very helpful for your review for your upcoming culminating test. So we will have here one projectile sample problem. Projectile C recorded an initial velocity of 8.21 meter per second at 40 degrees relative to the horizontal. Let's figure out the maximum height and its final velocity. Okay, before we will be dealing with the problem, let's try to recall first the two types of trajectory. We have asymmetrical and symmetrical. Asymmetrical, it has a initial height, let's say 2 meters, and then you have the trajectory here, and then here's your projectile. For symmetrical, it's perfectly like this. The launching and the landing of the projectile is same in position. While in asymmetrical, here's our launch and this is going to be our land. So they don't have same direction. So in this problem, an initial height is not provided. So therefore, we can assume that this kind of problem talks about symmetrical trajectory. So a projectile Z is moving in this curved parabolic path or trajectory at an initial velocity of 8.21 meter per second and then 42 degrees relative to the horizontal. Let's figure out the maximum height and then the final velocity. Say for example, this is our horizontal here, and then our initial velocity recorded. Let's say this is our 8.21 meter per second at an angle of 42 degrees. As we all know, we have x VIX component, initial velocity component, and of course our VIY. When this particular projectile will be at the max height, let's say this is going to be the H max that we need to figure out. As we all know, when our projectile is going up, its velocity will decrease. When the projectile is at max height, the velocity will be equivalent to our VIX. VIX remains constant in our projectile. So the values stay the same. And then once they are at max height, remember that VIX is equivalent to the initial velocity recorded. And then the only thing that becomes zero here is our horizontal or our VIY. So same, when it goes up, it will have a high meters covered, and then it will decrease. And then once it will be at the max height, the VIY becomes zero. Only the VIY becomes zero because our initial velocity is constant, recorded initially 8.21 meters. So therefore, it will equate to our VIX, which is constant all the way to our projectile or our trajectory. And the projectile will go down, everything will reverse. The velocity vector will increase its velocity. So from smaller arrow, it will just mirror what the arrow in the rising motion, but the direction will just change. It will go down. Same with our VIY. Now it's getting longer because it's increasing. But our VIX will remain same. So let's assume that it's having the same length. Okay? So that's what's going on here because we have another problem here. Let's find the final velocity before hitting the ground for sure. Okay, so in a perfect trajectory, we can say that the initial velocity of 8.21 meter per second will just be the same with the final velocity here, because it's perfect projectile, it's perfect trajectory. So whatever the values as it goes up will be the same as it goes down. It's just that the direction will change. So let's say, for example, here we can say that our velocity is changing its direction, and with respect to the horizontal, this is our horizontal here. So this is still 42 degrees. But if you notice, VIY flips because it changes direction, and our VIX remains constant. It doesn't change. Our initial velocity, as expected, to be 8.21 meter per second, but we can have the negative as it goes down. Let's try to find out how to do it. Okay. Okay. So let's have first the maximum height. In our symmetrical trajectory, when we want to find the maximum height, we have to follow this formula. H max, or maximum height, is equal to v squared sine squared theta over negative 2g. We can rephrase this one as vi sine theta squared over negative 2g. Our given in the problem, we have vi, that's 8.21 meter per second. Our theta is 42 degrees with respect to the horizontal. And then we also have, of course, gravity, and we will be using negative to represent the direction. And yeah, in our formula, we don't need to have the velocity value in the y direction and the x direction, because our formula, it just need the vi here. So we can use the 8.21 here. I will use this formula to have less errors when inputting all the data in your calculator. So I will use this formula. The vi sine theta then squared over negative 2g. Let's substitute the value of vi. It's 8.21 meter per second. And then the sine, the value of our angle is 42 degrees. And don't forget to square it out all over negative 2 times negative 9.8 meter per second squared. All right, let's get the value of our VI, or initial velocity sine theta, by inputting our data carefully in our calculator. So 8.21 times sine 42, and the answer is 5.49, and then our unit is meter per second. Don't forget to square it out. And then negative times negative, you will have positive value. It's 19.6 meter per second squared. Then let's get the squared of 5.49. 5.49 times 5.49. The answer is 30.14 meters squared second squared. And we will divide it by 19.6 meter per second squared. So we will divide it by 19.6. The quotient is 1.53, or rounded off to 1.54, and we can cancel unit here. As you can see, we have second squared, and we have we will just omit the squared here and meter, so we have the remaining unit, which is meter, as our max height with respect to the horizontal. Okay, so meaning we measured from the bottom to the top. But if the problem will say with respect from the max height all the way to the ground, of course we will have negative here as our answer to show its displacement. But in our problem, maximum height with respect to the horizontal, so from the ground all the way up, so we can have the value of a positive. But if ever that the problem says from top to bottom, you will have the negative answer. to represent the displacement from top to bottom measurement. All right, so we need to find the final velocity. Final velocity is this blue vector here, not the Vix or even the Viy, just the uh, vector here that is going down 42 degrees with respect to the horizontal. We need to find the value of that. As I said a while ago, the launching and the landing in our perfect trajectory, it's the same. It's almost the same. So we expect that our answer will be closer to 8.21. Okay, so let's try to do it. And if you noticed in the drawing, if I will transfer the VIY, I will not change the orientation, but I will just transfer it here. This is our VIY, right? If I will transfer, it's the same measurement in here. We come up with our right triangle. And if that's so, in order for us to get this hypotenuse here, this is the hypotenuse, right? In order for us to get this, we have the angle theta, we have 42, okay? And we have the value of our VIX and VIY. We can get it because we have theta angle here. So we can get the final velocity by using the Pythagorean theorem. So we can say VIX squared plus the VIY squared. So let's try to get the VIY. I guess we calculated already. Let's go back to our previous calculation. This is VI sine theta. And to get the VIY, all you need to do is initial multiplied by the sine theta. And to get the VIX, we have initial velocity cosine theta. VI sine theta is here. VI sine theta, we calculated it, and our value is this 5.49. So we will put it there 5.49 meter per second. What about the cosine of 8.21 times cosine 42 as the angle? So our answer will be 6.10 meter per second. So we will plug into our equation here. So VIX, it's 6.10 meter per second. And then don't forget to square it out plus the value of y. Value of y, it's 5.49 meter per second, then squared. 6.10 raised to 2. The answer will be 37.21 and then meter squared per second squared plus squared of 5.49. The answer is 30.14 meter squared second squared. But yeah, don't forget, we use this equation to get the VIY and the VIX. Let's continue. We will add now 37.21 plus 30.14. The answer is 67.35 meters squared second squared. And let's get the square root of it. Square root of 67.35. The answer is the answer 6. I will do it again to make sure. 67.35. The answer is 8.2006. If we will do the getting of the square root, we will remove the radical sign and the squared here as well and the squared here as well. So the remaining unit will become meter per second squared, or we will refine it. Remember, it's downward already, so we can use the negative root to represent the direction, and we will refine it more. And if you can see, the initial velocity recorded in the problem, it's 8.21. Since it's a perfect trajectory, our final velocity almost hitting the ground will be the same. Okay, so that's how you will get the final velocity. Again and again, final velocity in our velocity vector. This is our final velocity. And the rest is just our Vix and then Viy. Thank you for watching, and I hope you will never forget to, subscribe to this channel. And good luck to your evaluation very, very soon. Have a great weekend. Bye for now.